add these two polar coordinates. So I'm going to need to make myself a vector that's 30 degrees long at 50 degrees and one that's 10 long at 170 degrees. And we're supposed to add that. When they start with it in polar coordinates, your final answer needs to be in polar coordinates. With these word problem kind, you can just leave them in rectangular form. But when it starts in polar form and then asks you to add them, you need to put your answer back into polar form, which makes it a little bit harder. This is going to be a little bit longer video. It might even be 2 parts because it's so long. So let's look at this one. First thing you want to do is you want to draw these out on your coordinate system. So we have, let's see, I like to draw the whole thing. In the book, they don't draw this whole thing. If you don't feel like you need to draw out the whole coordinate plane, you don't need to. You can just put your 50-degree angle down. So it's supposed to be 55 degrees. I wrote 55. So we have a 55-degree angle, and it's 30. This is 55. And the vector length is 30. And then this one over here is 170 degrees, so that's almost 180, so it's down here, and it's 10. I guess I should make this guy a little bit shorter. So this is 10, and this would be, if this from here to here is 170, that means that this has to be 10 degrees. We're going to put these into rectangular coordinates just like we did in the first problem. We're going to add them together and then put them back into polar coordinates. So here we go. Let's try doing it, let's draw a triangle. This is our x, this is our y. We know that y is going to be sine. So I'm just going to put 30 sine of 55 degrees equals y. I just did that shortcut step that I was telling you about before. So we put that in our calculator, we're going to get y equals 24.57. And then we get x. We would say 30 cosine of 55 equals x. And we just put that in our calculator and we get x equals 17.20. Now let's go over and do this one real quick. We're going to get, here we go again, let's draw a triangle. This is our x, this is our y. So we say 10 sine of 10 degrees equals y. Put that in our calculator and we get 1.74. And these are all should be approximately. Sometimes I forget and just write equal, but since we're rounding, we want to say approximately, and that's what means approximately. Then we would say 10 cosine of 10 degrees equals x. Put that in our calculator, we get x is approximately equal to 9.85. So we have our two, we can put these in rectangular coordinates and add those together. I'm going to need to make some space on the board again. We're just going to have to work sideways here. And I don't think we're going to get this in the 10-minute YouTube slot. So let's write these in, let's take these and write them in our rectangular coordinates. So we have this one right here, and this one's going to be 17.20 right plus 24.57 up. That was the first one. Let's take the second one. We have minus, because you'll notice that we're going the negative direction. Our x is negative, our y is still going to be positive. So we're going to have negative 9.
On the sign.
Okay, so we have 1.73 up for that one. 1.74 up. Then we just simply add these together, and we're going to round it to 2 places, and you're going to get, for a final answer, I'm going quick here, 7.36 right. I'm going to switch this side so you can see the problem. Plus 26.31 up. Now, this almost seems like it could be the final answer, but remember I said if you start in polar form, you need to change this back into polar. So I'm going to plot these points. This is really, when I say up and right, it's really just, you're just really making the points 7.36, comma 26.31. It's really just coordinates. So I'm going to plot those 2 points. We're just really going to sketch this to look like something like this. This is not to scale. This is your 26.31, and this is your 7.36. Now to put it back into polar form, we need to find theta, and we need to find the hypotenuse, because your polar form is this vector length and the angle. So we have to use the Pythagorean theorem, which is not fun because look how we have decimals. So we need to find the Pythagorean theorem. We'll just call this h for hypotenuse. So we would say h squared equals 7.36 squared plus 26.31 squared. And then we would take the square root of both sides, like this. And we're going to end up with h. You're simply going to use your calculator. Everything's going to go in your calculator, and we're going to get our hypotenuse is 27.32. So that's our number. If we're going to put our final answer, it's going to be 27.32, and then we need to put our angle in this little thing. So do you remember how you get your angle? We're going to get the tangent of theta equals opposite over adjacent. So it's going to be 26.31 over 7.36. But we want what theta is, so we're going to take the inverse tangent of both sides. So we're going to get theta equals tangent, the inverse, of 26.31 over 7.36. You just put this in your calculator with your inverse tangent, and out will pop an angle. So our final angle that we need is 74.37 degrees, which would be this angle right here.